This lesson is on independent and dependent events, working with probability. So here are some definitions of independent and dependent events. I do want you writing these definitions down with the examples inside the boxes here. So when you look at independent events, it's if the occurrence of one event does not affect the probability of the other. And sometimes what you'll see with independent events is if you have an A and a B event, they are independent with the probability of A and B. So what you do is you would take the probability of A and then multiply the probability of B. So they do not affect one another with independent events. With dependent events, it's the occurrence of one event that does affect the probability of the other. So here in this box it says if A and B are dependent events, then the probability of A and B is going to be probability of A times the probability of B after A has happened. Here are some examples of what independent events and dependent events look like. So for example, for an independent event, you might have a history class, and it says the history class I take next year is independent, which means it does not depend on the math classes that I have taken. So history class, math classes, doesn't matter. They're independent from one another. Whereas a dependent event is the math class I take next year depends on which math I have already taken. So with dependent events, like for instance this math class, the math class you take year after year depends on the class you took the previous year or are currently in. So here's some more examples of working with independent and dependent events. So here they want you telling me whether each set of events is independent or dependent, and then explain your answer. So for A, 1A, it says a number cube lands showing an odd number. It is rolled a second time and is showing the number 6. So the first time they rolled, it showed an odd number. The second time it's rolled, it's showing a 6. So this is an independent situation because the results of rolling the number cube the first time is not affecting the results the second time they rolled the dice, or the cube. For B, it says one student in your class is chosen for a project. Then another student in the class is going to be chosen. Well, this is a dependent because choosing the first student leaves fewer students to choose from the second time around when you draw. So when you're choosing a student, you pick a student's name. Well, that's one less student you have to draw for a project, so that would affect the group members for a particular project and who's in that group. Here we have another example. With this, we are going to be working with probability to figure out what it's asking. It says an experiment consists of randomly selecting. So we're randomly selecting a marble from a bag, and then we are replacing it. And then we're selecting another marble. The bag contains 3 red and 12 green marbles. They want to know what is the probability of selecting a red marble and then a green marble. So probability of selecting a red and then selecting a green marble. So this situation, because the first marble is replaced after it's selected, the sample space for each selection is the same. So these are independent situations because you are taking a marble out, but then you're putting it back after you've selected it the first time. They want to know the probability of selecting a red marble and then a green marble. So we have 12 green and 3 red. So what we have to do is find the total amount of marbles in the bag. So we add 12 plus 3, which is going to give me 15. So the probability of selecting a red times the probability of selecting a green, what we do is we take the total 15. Red is going to be 3 out of 15 because 3 out of 15 we have the likelihood of pulling a red. Likelihood of pulling a green the second time is 12 out of the total 15. So it's 3/15 times 12/15. 3/15 is representing the red marbles, and the 12/15 is representing the green marbles. Then what I do is I can simplify these fractions down if they can be simplified, which they can, to be 1/5 times 4/5, and then you just multiply across. 1 times 4 is 4, 5 times 5 is 25. So the probability of selecting a red marble and then a green marble is going to be 4/25, and that would be my final answer. Our last example here, we have a bag with marbles in them. It says, suppose an experiment involves drawing marbles from a bag. Determine the theoretical probability of drawing a red marble and then drawing a second red marble without replacing the first one. So here's our first draw. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles. 3 out of the 9 marbles are red, and we have 1, 2, 3, 4, 5, 6 out of the 9 marbles are blue. Here our second draw, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 2 out of the 8 are red, and we have 6 out of the 8 blue. It says the sample space here for the second draw is not the same as the sample space for the first draw. There are fewer marbles in the bag for the second draw. This means the events are dependent of one another. They want to know, what is the probability of drawing a red marble on the first draw here? Well, we have 3 red out of a total 9, I said, so the probability is 3/9, and that simplifies to 1/3. The second question is asking, what is the probability of drawing a red marble on the second draw? Again, I mentioned we have 2 red out of the total 8, so we have 2 8s, which simplifies to 1/4, and that would be your answer there. So you really have to pay attention to details of the word problems here and just writing out the probabilities and determining if it's an independent or dependent event taking place.